In this episode, we're going to go ahead and take our hosting a lobby to the next level to where we can actually have people join in, have their player objects spawn, and allow them to control their character. Also have them look differently from our character as well. Before we get too far into it, there's a few changes that I forgot to include in the previous tutorial. We're going to add, just for debugging purposes, to our Steam object, we're going to add an asynchronous Steam event. We want this to be a function that will listen to any asynchronous event that occurs through Steam, any response back from Steam, and we want it to just log that to the console. This will help us whenever we're trying to troubleshoot whether or not a player is joining, if we're actually getting that thing. For example, if you click join and nothing's changing on your screen, and the server is actually seeing that somebody attempted to join, maybe our logic on the client end was incorrect because the client doesn't have anything that doesn't know what to do when it receives that response back from the server. So we're going to leave this here kind of as a logging thing in the background. Another thing we needed to change was in our player object, I had you add a variable definition down here, lobby member ID. That means we don't really need this here. But I also forgot to have you actually use that lobby member ID. We're going to set our image index equal to the lobby member ID. The purpose for this is that the sprite that I'm using for the player, depending on what index you have, if you're player 0, 1, 2, 3, I just give you different colors. That way we can visibly see who is what player. And we can also make sure it matches up amongst everyone else in the lobby, that everyone sees the same thing, right? So that'll be useful. So just those two things before we continue on. This video is going to talk a lot about buffers. If you don't know what a buffer is in GML, that's okay. It's a weirdly weird concept that I haven't fully wrapped my head around, but here are some helpful videos that could probably guide you in the direction of understanding what a buffer is and how it's utilized in GML, or in any language for that matter. The first things first, we're going to touch on the server. What we need to do is that when the server receives an asynchronous response from Steam telling you, hey, a player has joined, we need some logic to happen. We need to actually capture that logic and see what goes on. So we're going to say this is server listener. Because I added that asynchronous listener to show pretty much any JSON event that occurs, or sorry, any asynchronous event that occurs, I'm actually going to show you what happens when somebody joins. So if I host a lobby, you see these things that are popping up down here. It says I joined the lobby, because that's me joining. But if I try to join it from a different client, you'll notice that this lobby chat update occurs. Now, nothing happened here because I don't have any logic programmed for that. But you'll notice that we're looking for this information. So we're getting this event type, which is what we're going to be searching for. That's the event type. So for lobby chat update, we want to do something to occur. And we're going to use that user ID, and we're going to use the change ID to see what kind of change had occurred. So at this point, what we're going to do, we're going to create a switch statement, switch async load, and we're looking for the event type. And we want the case to be if it is indeed a lobby chat update event, to do the following code. So we want to know who is this coming from, right? So we're going to call the from IDs equal to async load user ID. And that's having us get this information right here. It's taking this gobbledygook and turning it into, a Steam ID, an actual legible Steam ID. So we'll have this say that's the Steam ID that we're getting. And we're going to get what's their name. So from name, and we're going to use a Steam function to get that name. So Steam get user persona name sync, and we can get it from the Steam ID that we just got earlier. And that's their Steam player name. And this other thing is if kind of determining whether or not a new player is entering the lobby. So that's what we're piggybacking off of this change flags thing. I'm not totally sure just yet as far as what flags exist, but we're just seeing if it exists, if it means this Steam lobby member change entered like someone entered the lobby, if that change had occurred. And if it did happen, we want to then, well, we got to spawn that player, right? That's the logic the server will do. The server will issue the spawning of someone who is joining, like a client who's joining it. So we'll just have it show a debug message. Debug message, and we'll say player joined, and we'll put their name, right? So from name. And their player slot is length of our array at this point. So that kind of helps us know what player slot they are. So this will technically be player 1 as far as the slot's concerned, but that will allow us to use the red sprite, the next sprite over. This is just aesthetic logic that isn't important necessarily to Steam, but is important visibly for us. And we want to push to our player list a new player, right? So every new player has a Steam ID. It's going to be the from ID. They have a Steam name, which is going to be the from name. They have a character, which initially undefined. Start position will be a spawn point from their slot in this scenario. That's their player number in this case. That's what we've called it. And we want the lobby member ID, which is also their slot. Their index in the whole object. And that's all the logic we need to pass to this player list. Now, we haven't spawned them yet. This was just simply us adding them to our server's array of players, right? Our player list here. But now that we've added that logic, so they exist in our server maintained player list, we can now, we need to send the player the state of the game, like where everybody else exists, where they're spawned at, what their Steam IDs are, what their Steam names are. If player 3 is joining, they need to know who player 1 and player 2 are, right? So we're going to sync them over. So we're going to make a new function. We're just going to call it send player sync. And we're going to send our Steam ID along with that function. And we're also going to then, once everything's synced up for that player, we're going to tell them to spawn afterwards. So we're going to do send player spawn. And give that slot number as well. Now, these functions don't exist. These are functions that we're going to create. I just wanted to kind of let you know our logic as far as what we're doing here. And that's, as for any case, you got to put a break at the end of the case. So let's go ahead and set up these functions. We're going to put this under a script file, and we're going to call this script file lobby management by the server. This up here. Now we're going to make these functions send player sync, and it's going to include a Steam ID. And that's all we need from that one. And another function was send player spawn. And that's also going to take a Steam ID and the slot. Now these, we only want these to be invoked by the server object. So whenever we're referencing variables, that we don't have to pass the server object over to it, we're just going to say that the self reference of these functions is going to be obj server. That way, whenever we're referencing, for example, like player list, it knows to reference, well, it will reference the server object, will reference this player list. So that'll be useful. Let's go ahead and copy that. I'll just put that above that. Okay. So for this first one, we need to send data to the client through Steam of all the players. And there are various ways you can go about doing this. And this is kind of where your ingenuity, your creativity can come through. But you need to understand how to utilize buffers. So we want to, in this case, I want to say we're sending a JSON dictionary over Steam. So first we need to create the buffer. So just an empty variable to toss it in. We're going to do buffer create. Initially, we're going to make the buffer just exist as 1 byte. And we're going to have it grow in size as we don't know how big it's going to be because this array of players, right? This player list object here it could have a lot of players. What if your game supports up to 20 players? This could be very large. And maybe this isn't the best way to send this kind of data over. Maybe there's a different way you go about it. But I know this will work. It just may not be the fastest. And you'll see that kind of latency as we get in there. So we create the buffer. We're telling it here that to start existing is the size of 1. Buffer grow means that we're not really giving it a fixed size where like it's going to be 1 byte and that's it. We're saying that this potentially could grow very large, but we're wanting to start with 1, and we also want to have the alignment set to 1 as well. So it starts at the very beginning too. And we're going to write some data to it. So buffer write. And this is kind of where a lot of the logic is going to kind of matter. This is where the thick meat and potatoes of all this stuff happens. That kind of confused me at first. We want to write to this buffer an identifier. We want to tell whoever's receiving this object of data knows what its purpose is for. And when you read a buffer, you have to read it sequentially. You start from the beginning and then you read it on. You can't just jump around. Like if I have what array equals like 0, 5, 6, 7, whatever, equals all these things, I could be like, oh, well, what's the array item of 7 or something? Or what's the 4th array item in that whole array? Oh, it's 1. Oh, okay, that's what it is. You can't do that with buffers. With buffers, you literally have to read each item like as it goes through, like the first item, the second item, third, fourth. You can't, you have to read it in order. You can't jump around when you're reading a buffer. So we're going to use this and say the first buffer, the first entry, the first byte that's sent in these bundles of data, these packets of data that are sent to everybody, will be the identifier. It will be the packet that determines what the receiving end needs to do with the data. And so we're actually going to use this packets script that we have that's currently empty, and we're going to create a enum, and we're going to call it network packets, and it's going to allow us to kind of create a dictionary of entries that we can use for reference later on in our game, anywhere in the game. Now, once again, these numbers that we're giving it, totally arbitrary. That first packet is a U8, and that could be anywhere from a number 0 to 255 or 4 or something like that. So it could be any one of those numbers. So we know those exist. So for this buffer, we want to identify it with that first packet. So network packets, and we're using the sync players packets. That means, so as a client receives this packets, they know that this data, as we go on, will be used for syncing data. And we're writing a string to the same buffer, to just a buffer string, and we want to essentially dump the player list here. I don't know if you know this, but whenever you print out a character, like an object like this, it's going to spit out all of these objects inside of its variable. It'll also send over all this stuff, which isn't super necessary. So what we're going to do is we're going to make a function that kind of shrinks the player list. We're going to call this shrink player list. And this function, we're going to make it just remove the character from the player list, because the character, whenever we do this first initial sync, we don't really need that. I mean, maybe if each character had like a sword or a different cosmetic item, maybe that kind of stuff would be important. But for our purposes, we just want to send over some basic stuff like their Steam ID, their position that they're at. That's pretty much it, what player number they are. And so we're just going to create a function down here, and we're going to call it shrink player list. And we're going to copy the current player list that exists. We're going to iterate through the entirety of the player list. We're going to take the character variable, make it undefined, and then just return the string version of that now modified or shrunken player list. And that'll be easy. So back to what we're doing up here. We now have this string that is technically a JSON string that we can then, on the receiving end, parse through. But now that we have that, we need to send it to the player, right? So we're going to Steam net packet send, and the Steam ID that we're sending it to, so Steam knows who to send the packet to, and the buffer we need to send over to that Steam ID. And then once we're finished with that, to save on memory and not totally overload the system, we need to delete that buffer that we just created. And that way, our system then a clean slate after it sends over that packet, and we're good. So that's that function. It is now sent over our player list object that's filled up with all the players, or maybe just ourselves, to the player that joined. Now we also have it, after that's done, it ends to tell the player where to spawn right afterwards. And so first off, let's grab the position they're respawning in. Grab spawn point, and we're using that slot or what player number they are. And we also need to create a buffer, because this is another bundle of data they're going to be using. Now we actually know how large this one's going to be, because we're not doing a string, we're doing an exact amount of data that we know that's predictably 5 bytes. And it's a fixed amount of data. We want to start at the first packet. And the way we're going to logically split this up is the first byte will be an identifier for what this packet purpose is for. The second 2 bytes are going to be the position in X, and the second 2 bytes will be the position in Y. And that's really all we need for this, because we're just telling them to spawn at a certain position. So we're going to do buffer right to this buffer we just created. And the identifier is the smallest packet possible, buffer U8. And it's network packets spawn self. And we need to give it the X position. So buffer right to the same buffer, buffer U16. The reason why we're using U16 is in the event that the X value in your map could get very large. For example, our X value, I think the biggest it can get is to 640, 639. It's like the resolution I set. And so a buffer U8 couldn't contain that number. It's larger than 254. So we have to use the next size up. Maybe you could do some fancy logic, and maybe you don't want them to ever spawn over there or something like that. Maybe you never expect a player to be in that position over there. Or I don't know. But in this event, because my maps, the X value could potentially be larger than 255, I have to get a bigger buffer size to include that data. And so now that I have that, I can get the X position there, and we need the Y position. Now you could argue that my Y position technically never gets larger than, oh, I guess it does. But what if it was like very tiny? What if my X and Y values were very small? Or my Y value was very small, but my X value was very large. Like what if you had like one of those vertical shooters, right? And maybe your X values could be really small, but your Y value is large, and you could make an argument, well, maybe I can make my X position a U8 instead of a U16. You could, and that would be more efficient. But 5 bytes is already super small. So, I mean, up to you. Let us go ahead and send that packet over. So Steam net packet send to the Steam ID that we were given and the buffer that we just created. And let's go ahead and after that is sent, we don't need it anymore locally, so we should delete it. And now that we told that guy where to spawn, we should probably tell ourselves where to spawn the player as well. Because we grabbed this point, right? And we're telling the player, hey, you can spawn now. But the server still needs to tell him to spawn, because nowhere, we haven't told the server to spawn the player yet. So we need to do that here locally as well. So we're going to say server, we're going to make a function called server player spawn at position, right? And we're going to give it the same value, Steam ID, and the position that we already defined earlier. And if there are any other players that exist, we probably should also say, hey, you guys need to spawn this guy too. So we need to have some kind of function that takes care of that. Send player spawn, send other players spawn. And they need to also know the Steam ID, and they need to also know the position that the player is going to be spawning at. So you can kind of see how this logic is working. We're telling the guy who joined where to spawn. We're telling ourselves where to spawn the guy. We're telling everybody else who also exists in the lobby where to spawn the guy. It gets a little tricky when you start working through all it, but it all makes sense in the end. Let's go ahead and create this server player spawn at position. Server player spawn position. It's going to take Steam ID as a variable. It's also going to take the position as a variable as well. The way we want this logic to work whenever responding a specific player with the Steam ID, we're going to want to not only spawn that player with a bunch of information attached to it, but we also want to modify our player list object with whatever character we just created, because we don't want this to be undefined. We want it to be defined with whatever character instance was created, right? So that way, if we need to reference it with logic at any point in time, we can't. Like, for example, if some player disconnects, we want to remove that player's, game object, that player's character. We could have a asynchronous event that would say, hey, this player just disconnected. We need to clean up after he left. And so we would know, well, in our player list, the reference to that character is right here. Just delete it. All right, cool. Good. With that in mind, we're going to iterate over the entirety of the player list and create the player object based off of that. So if the index of our player, if that Steam ID equals the Steam ID we're given in this particular function, we want to actually spawn the player. So let's go ahead and create a reference to that instance that we're going to be using. We want it to be created at the X position and the Y position that we were given. The layer is the one that we previously identified. We want it to spawn a OG player at that location. And we need to have the following information kind of embedded into it. So that is, once again, the Steam name, which is going to be the player Steam name that's already in this, already assigned to this entry, this array entry. We want to also give it the Steam ID. We give it, technically, it's the exact same thing. Oops, comma. As what I just put before, but I mean, just for consistency's sake, I guess. And lobby member ID will also equal the index in this section. Now, so this means that with this player object that is created, we have the Steam name associated with it, the Steam ID. That way, they can we'll know if it's a locally controlled character or not, which obviously it isn't, but and what their player number in the lobby is, if they're player 1, 2, 3, or 4, whatever. That's also useful to know as well. Now that we've created that instance, we need to reference the player in our player list and give them a reference to this instance. So now in our player list, whatever number they are here, their character reference will not be undefined. It will actually be this object, this player object. And then one last step, we got to do the send other player spawn. Also only want it to be called by object server. So we already have the position. We don't need to create it, but we need to create a buffer, right? So have it be buffer create, and essentially the same thing as before. 5 actually needs to be a little bit larger because we are going to include the Steam ID as well, because the other players need to know if this player is being spawned, whose Steam ID is it associated with. There might be an easier way you can go about it, but this is the way I went ahead and decided to do it. So it's actually going to be, the total buffer size is going to be 13. It is a fixed buffer. I'm going to start at packet 1. And the reason being is because we're having the first packet, always the identifier packet, right? Telling the client, hey, this is spawning somebody else. The second chunk, like the next 2 bytes, is the X position, Y position, and this last section is actually 8-byte large. This is the Steam ID. Now, I don't know if you know, but Steam IDs can get a little bit larger, and we'll see that later on. But it is like 17 numbers apparently. Yeah, that's a 64-bit ID essentially. So even then, I mean, a 16 size byte or 13 size buffer, a 13 byte size buffer that we're sending over isn't massive. We're not doing it every second. This is only when somebody joins, so it's not that big of a deal. going to be the identifier. This is a network packet of spawn other. And then the next section of bytes is just buffer U16. That is the position X. That is position Y, which is a buffer, U64. And that is the Steam ID that we pass through to here. Now, we want to send this to everybody in the lobby except for the player who spawned, or I'm sorry, except for the player who joined, and except for us, because we already know we don't need that packet, right? So we're going to iterate through the entirety of the player list, but since we don't need to send it to us, we could just put 1. But just in case, because we know we're always 0, right? We had it set here. Player list 0 is literally always us. So we're just going to put 1 here. And we're going to have it iterate through the length of the player list array. If player list with this index value Steam ID is not equal to the Steam ID of the player that joined, we could have it do the following, which is Steam net packet send player list send that person, send that buffer to that person. So if the player we found doesn't equal the Steam ID of the player that joined, go ahead and send them the packet of this information. Hey, this guy is spawning at this position. Go ahead and create them in your game. So that's that. And once we're done with the whole buffer, we're going to exit out of here. We got to delete the buffer, right? That we don't have random bits of memory just hanging around, wasting space in our game. Cool. So at this point, the server side of logic is finished. This is a lot, and we're almost done. I know this is a long video, but this is all the heavy work we got to do just to spawn the freaking player. It's disgusting. I get it. But now we need to go to the client. We have to actually work on the client information because we're sending all these packets over, right? All this information is being sent to the client, but the client, as of right now, has no idea what to do for it. It's not listening for anything. It's just an empty object that's just sitting there. Let us go ahead and create that stuff. So on the client, we're just going to use 2 events. We're going to use a create event, and we're also going to use a begin step event. We could put it in the step event. I'm not sure if it really matters, but just for cleanliness, for anything that we're listening for something to occur, I want to put it in this begin step event. And so that's how we're going to work that out. So in our create event, this is just going to be init client variables, right? And this is going to be very similar to what it looks like on our server. If you look at the server, when we start the client variables, we get all this information. Let's go ahead and just copy all this stuff and go over to client and paste everything. Oops. We want the player list to exist. That's fine. Steam ID, that's fine. That's fine. Let's go ahead and add a lobby member ID. We might not need that. Maybe I should add the service one. We're going to add it there for now anyway. And we're going to add this as well here. That's fine. Now, there is 2 more things we do need to add that is a little bit unique. Because remember, we are listening for information here. We haven't defined much listening on the server yet. We will in the future. But for this episode, we want to have a base in buffer that's going to be created. And we're just going to have it create a basic buffer. This is important. But that way, because we're going to be modifying this buffer over and over and over and over, because we're always going to be listening and it's always going to change. But this just creates an empty point in memory for it to know that we can use this variable to constantly iterate over it. Yeah. All right. So at this point, we can go ahead and go to our begin step, and let us go ahead and change this. We're going to say this is our listening for activity as a client, right? And this is where we're going to be receiving packets. So the way this works in GML is that it's the way they suggest you do it, and maybe it's not the best way, but it's the way the demo did it, is using a while loop. And essentially, while Steam net packet receive, while that's occurring, do some logic. And it doesn't get stuck. It's interesting how it works, but it's just the way I've seen it work. And this is the basic setup for it. So first off, we need to know who's sending the information, right? Steamnet packet get sender ID, and that will tell us who was the one that actually sent us this information. And we're gonna set this information into a buffer that we have. Net packet get data info. And this is where that buffer that we created here, I mean, I said that we're creating it to a buffer that can grow, but right here is where its contents totally changes, like every time. But it needs to be a buffer to begin with, and so that's fine. And then we're wanting to make sure that when we begin reading through this buffer, seeking through it, as they call it, that we are starting from the immediate seek start beginning of the buffer, the very, very, very first byte that's in there. We want to start from the very beginning. We also need to now kind of have some kind of reference to what is the very first packet in it. And if you remember, we decided that the very first packet in any of these buffers that are being sent over is determined, or determines what to do with the rest of the data that's inside the buffer. So we're going to have a switch statement, kind of similar to how we did the asynchronous stuff, or where is it? Similar to how we did asynchronous stuff, to where based on what occurred, we're going to do the following. So with that same behavior, we're going to determine the type of packet this is based on what the first chunk, what the first buffer, what the first byte is received in this. So with the type, we're going to switch on what type of data was received. And so for the case of network packets, what do we got? Sync players. Whenever that packet is sent over to us, we want to do the following, right? So let's start with, before we get too far ahead, I want to actually kind of clear up some stuff so that we can reference this as we work through it. Let's just close everything. So close all, and we're going to reopen the server and reopen the client. Cool. All right, so we know that whenever we see that somebody joins, we're sending a player sync, right? I middle click that, we get over here. So we know that the way this packet is done, the way this buffer is written, is that it first has the U8, and that is telling us what to do. That's the type of packet we're sending. And then we're sending this, remember we're sending the player list, right? Which was the JSON thing, it was a string. So we need to read a string. That's what we're expecting to get from us, we're listening for. So this player list, which is going to equal our buffer read in this inbuff, we're expecting a buffer string to be read. And now we need to, now that we've read it, we have it, it's just a big long string of text. We need to parse it as a JSON object. So our player list equals JSON parse list. There we go. So now we've turned that string into an actual readable JSON object. It's a dictionary now. And now that we have that, we can now sync our players based off of this newly acquired player list from the server. Ooh, great. Now, this function doesn't exist yet. That's okay. So we need to define it so that the client knows what to do with this, this player list that I just acquired. We're going to do that under a new file. We have lobby management server here, but we're going to do lobby management client at this point. So this sync players function, we're going to do something similar. We want it to only run on obj client, and so we want it to reference those kind of variables whenever it's working with it. And we're going to define it as sync players, and it's only going to be taking in a player list variable. For ease's sake, we're going to call it, this is the new list. This might make it easier to understand as we're working with it. The way we're going to work through this is we're going to try to gather all of the current Steam IDs that we have in our current player list that exists. We're going to just compile that into its own array. So it's just gathering all the Steam IDs in the player list that we have currently. Because maybe we've already been existing in the server for a while, and then somebody else joins in, or maybe they get disconnected and they rejoin, or maybe, I don't know. We want to be able to have some kind of function that we can use at any point in time to sync players up. And maybe we won't really need it initially, but this is the kind of thing that the kind of logic we have to work through when we're moving forward. So now we have that array of Steam IDs. Let's go ahead and now iterate through everything in this new player list that we just received. So we're going to say this new Steam ID is equal to the first, or whatever index we're at. So new list Steam ID. This is a function that doesn't exist right now, but if the array that we received doesn't include this new Steam ID, so if our current player list doesn't include this new player, well, we got to spawn a player for that player, right? And then we also need to then make this new list, this entry in this array, their character needs to now be this this instance that we just created. Then we want to push this new player to our existing player list so that they're there. So if our current existing Steam IDs that we have in our player list does not contain this new Steam ID, we want it to spawn this new player and take that, that entry of the player, the undefined character, right? And we want to set it equal to that instance and then push that new player to our player list. If in the event that a player that we join and that player Steam ID is already in our player list, for example, well, we have to then maybe update it. We have to sync it up with the server. Okay, super wordy, but that was a big part of syncing the players to make sure that our player list is synchronized with the player list that the server contains. That's super useful. I guess the only function that we haven't defined yet then is this particular function here, client player spawn at position. So just one last function. Hang in there, guys. Self. This only wants to be ran on the client. So off references will be for that. This will only take just some player info. Essentially, this is just spawning a player. So we need to know what layer we're spawning the player on. We want to know what the name of the player is going to be. Their Steam ID, lobby member number, is the location that they're spawning at. And now we can spawn the instance. There. Okay. And then we'll just have it return the instance. The reason why we're returning the instance here is because we're using it right here. We need a return value of the instance so that we know a reference for that. The last two chunks that we need here is these next two packets we have to have. So instead of writing it all out, this video is getting really long, I'm just going to read it out for you. So we needed to do something for the spawn other, because remember, whenever the player joins, it's syncing, which we've already done, but it also has to spawn them. And the first one, we're spawning ourselves, and then eventually we'll be spawning another person. So the spawning ourselves, we're handling right here in this packet. So whenever that player receives that packet, they're going to receive this guy. The identifier will determine this. So we're going to spawn ourselves, and the person we're spawning, we're also going to make sure that we're getting the right lobby member ID, because we're going to need that lobby member ID to determine kind of like our skin, right? Because when we spawn the player, we want to know what slot they're in, what player slot they are. Now, technically, we're always going to be 0 in this player list, but if for some reason when the player list syncs up and we change or something, I just went ahead and did this logic so that we're iterating through the whole thing, and where our Steam ID equals the Steam ID of the player in the player list, to set our lobby member ID also equal to that person's lobby member ID. Because they'll have this right here, right? Something should be defined there. Anywho, we choose what layer we're spawning on, we grab the X position from the buffer, then we grab the Y position from the buffer, and then we go ahead and create the character based off those two things. We then set that character, that object we just created, we set the reference to that instance to our own personal character value in our player list, and then also to what our client sees as our character. We'll break out of that. Now, for other clients that get the spawn other packet, we do roughly the same thing, but we also include the reading of the Steam ID that comes in from the buffer. Because remember up here, when we're sending the other player, we also include the reference to the Steam ID, the character that's actually the player in the lobby that's spawning. And so it's fairly similar as far as grabbing all the information. This is probably a little bit inefficient. It's probably lackadaisically done. We should be pulling the lobby member ID from the server, but in this tutorial, this will work for now. I'm not too happy with how our sync player works. We're going to work with that later, but this does visibly work for right now because we're not handling the intricate scenarios of disconnecting and reconnecting and when lobby player lists technically desync. But for now, this will get us by. This packet is mostly used whenever we are already in the lobby and somebody else joins. That's when I'm using this packet. It's to spawn another player as they join into the lobby. And with those two final changes, we should now be ready. Also, be sure earlier in the video, I did not include on the server object this lobby member ID. Make sure it exists there or else it will not work. The previous video I mentioned it, but in this video I noticed that throughout the video this didn't exist. But I'll go ahead and cut back to the video. With that last push, pull, reload, play. Okay, now we are at the point to where the client should not only spawn the host, but it should spawn itself when it attempts to join. Once it receives all the information, and cool. And now we can, right now you see that we're not syncing all the information, but the two players have joined and we're both in the lobby. I see that some of my other logic has gone through and this isn't supposed to happen. Your object button step logic, if you don't have this set, it will spawn various characters because of how we did it. We really only want this action to occur once. So we're going to add a little if mouse check button pressed and be left, then do that. Okay, so this will only do like once the button's pressed, perform that action one time, not let it keep happening. So do that. Aside from that, we are actually now in a position to where we are getting a player to spawn on both sides. They're syncing up, the states are syncing up. Obviously, we're not sending X and Y positions or action things. That'll be for the next episode, but this one was freaking long. But we have the framework set up to where both lobbies can sync up and connect, and it's actually working. So we are in a happy state. So this is good. This is good. Make sure you're pushing your stuff to your repo so you can get it running in both VMs. That you have a point of reference, to go to for when, and you have a point of reference to go back to whenever you have, messed up your code or something because you're trying out something yourself. Whatever it is, keep up your version control because that will help whenever you're sending different builds to other VMs that you have running. Because we could potentially run. Right now we're set for 4. The lobby is set to a max of 4, so the logic will work 4 different times. In the next video, we'll practice it with a bit more lobbies going on. This is just with two characters. I think this is a good stopping point. We did a lot in this one, but hopefully this has been a help to you guys. But all right, I'll see you in the next one when we work on getting actual player positions syncing up and input syncing up, so that way we can actually play a game together.